Okay, so today on this one, we're going to be simplifying algebraic expressions. We will go over vocabulary and simplifying algebraic expressions. I will use definitions to simplify expressions. So the first thing that we're going to look at before we even trying to solve them is we're going to go into our definitions. And our definitions are going to be term, which is a number or a product of a number and variables raised to a power. So each of those that we see right there, we've got 3, 5x squared, negative 2x, and 9x squared y. Each one of those is a term. And another way to think of terms is like a word in our sentence. And the sentence itself would be our equation. So each of the terms you can think of like a word in the sentence, which would be our equation. The next one we have is coefficient. Coefficient is the numerical factor of each term. So the coefficient will be in front of the variable, so it'll be the 5 or the negative 2 or the 9. And coefficients only go with variables when they're by themselves. They're what we call a constant, which is a term without a variable. When we're discussing like terms, they are terms with the same variables, but they may have different coefficients. And we see each of those, we have 3 groups. We have a 3x, negative 6, and a 21x. All of those are a like term because their variable is x. 2/5 y, 0.75y, 126y, and negative 32y are all like terms because they have the same variable of y. Looking down at the third group, we have 4ab cubed, 9ab cubed, and negative 7b cubed a. Now, although the negative 7b cubed a looks like a different term, it is still a like term because the exponent on the b matches the others, and the a does as well. Even though they're in the flipped order, they're in a different order, they are still like terms. So if we had an equation where we needed to combine the 4, the 9, and the negative 7, we could combine those because they are like terms. Now we go on to the distributive property of multiplication. And the distributive property of multiplication means that if we have any number outside of parentheses, we distribute it to all of the terms that are inside the parentheses. So if we had, our first example right there is a, b plus c, or a parentheses b plus c. And that would distribute out to be ab plus ac. Same thing with our next one, a, b minus c is going to distribute to ab minus ac. If we continue to look down at the other examples, 5 times x plus y is going to give us 5x plus 5y. That one's fairly straightforward. The next one that we have is negative 3 times 2 plus 7x. That will distribute to negative 6 minus 21x. Same thing on the next one, we distribute the 4 to the x, the 4 to the 6y, and the 4 to the negative 2z, which will distribute to give us an answer or an equation of 4x plus 24y minus 8z. This next one you can't see very well, but we have a negative outside of the parentheses, and inside the parentheses we have 4 minus m minus 7k. So if we distributed that, we can picture as though there's a negative 1 outside of the parentheses, because if there is no variable, if there's no coefficient outside of the parentheses or in front of the variable and we simply have the negative symbol, that's going to tell us that there is a negative 1 in front of it. So if we distributed a negative 1 through, a negative 1 times 4 is going to give us negative 4. A negative 1 times negative m is going to give us a positive m. And a negative 1 times negative 7k is going to give us a positive 7k. So that's how we got those signs swapped in front of our answer, which is negative 4 plus m plus 7k. So now if we're going to look at combining like terms, let's start with this 8m minus 14m. And so we see that they both have the same variable right here. The m are both the same, so we just combine the 8 and the negative 14, which is going to give us a negative 6m. And then over here, again, we have the same variables. So 6, and like we said before, if there's no number in front of it, if there's no coefficient, we treat it as though there is a 1 in front of it. So let me rewrite that little box right in front of it. So we have a 6a and a 1a, and combined that's going to give us 7a. Now this next expression, we only have 2 terms out of our 3 that we can combine, and that's going to be the negative y squared and the positive 3y squared. Combining those two is going to give us a positive 2y squared, and our constant over here is going to remain the same, so 2y squared plus 7. So now we've got our next equation, and our next equation is going to have 2 variables that we can combine, but it also has 2 constants that we can combine. So if we combine that 6z plus z, and if you wanted to rewrite it just to make sure, you could write 6z plus z plus 5 minus 4, if that makes it a little bit clearer on how you're going to be combining. Our 6z and our z combined are going to give us a 7z. Positive 5 minus 4 gives us a positive 1. So that expression combined is going to give us 7z plus 1. Scroll over to our next equation, which is going to be a little bit longer than the other ones that we've been looking at. So let me get it good and in the screen. There we go. So the first thing that I would do, let me zoom out because I can't see it completely on mine, is I'm going to come over here and put a square around what I want to combine. So I'm going to combine them with their similar colors. Got a positive 2 and a positive 12, and then I've got a negative 9x and a negative x. And so combining them, my negative 7 minus 2 will become a negative 9. And then my negative 9x minus x is going to be a negative 10. And then my constants of a positive 2 and a positive 12 are going to become my positive 14. Okay? So, and now I've got 2, I think they're pretty straightforward distributing. Instead of having to distribute to 2 terms, it's only got 1 term, so I'm going to multiply the 6 times that 4, which is going to give me a positive 24, and then I've got a negative 8, which I'm going to distribute to this 9, which is going to give me a negative 72x. And because there's only 1 term inside each of these parentheses, which is this term right here and this term right here, there is only 1 term that I have to distribute to, so that means my answer is only going to be 1 term as well. So now it's asking us to simplify each of these expressions by using our distributive property. And again, we can't just distribute to 1, so we're going to distribute to the 8y, and then we're also going to distribute to the 2. So that means our 8y times y is going to give us 8y, and 8 times 2 is going to give us a positive 16. Next, we have 3 to the 7a, or 3 times 7a, and then we've also got 3 times negative 5. This is very important to remember that little negative right there. Let's We need to not make simple transposition errors of forgetting our negatives. So 3 times 7 is going to give us 21a, and 3 times negative 5 is going to give us that negative 15 that we see there. Is that, now we've got one more over here, and again we're going to distribute to both terms inside our parentheses, and 6 times 5 gives us 30, and 6 times negative y gives us our negative 6y right there. This next thing is going to ask us to simplify each of the expressions. So when we are simplifying, the first thing that we need to do is distribute. So we are going to distribute first. That positive 5x, or 5 times x, gives us plus 5x right here. And 5 times negative 2 is going to give us this negative 10 right here as well. And since there are no like terms, we have a y, we have an x, and then we also have a constant. See how there's no variable right here? It means we cannot combine any of those at all. So this is as combined as we can get that equation. Now we've got this one right here, same process. We're going to do 5 times both of these, which is going to give us our 15x. It's going to give us a 30z, and then it will give us a negative 4y because it is not distributing anything to that. And once again, we have an x, we have a different variable of z, and then we have our y variable, and they are all separate variables, so we cannot combine them, so that is completed. Now let's look at this nice little pretty long one. We're going to distribute the 4, and then we will distribute the 4 to the 3, and then we're going to distribute the 5 to the x. Actually, you know what? Getting slight step ahead of myself right here. So the first things that we're going to do is we're going to have our 4 times y, which is going to give us 4y right there. 4 times 3, which gives us our positive 12. So that is the first step in the distribution. Now we come over here and we see that we still have parentheses over here, so we're going to distribute the 5 to the x and the 5 to the positive 1, which will give us our 5x and our 5. And over here we have our 4y still, and we're going to just bring those down. And if we notice, right here we have a positive 12 and a positive 5, which are both constant. They neither of them have a variable, which will give us our answer over here of positive 17. And the y cannot combine, and the x cannot combine. So these stay separate. The only things that we combine in that equation is our 12 and our 5, because they're both constants, and we are adding both of them, so it becomes 12 plus 15, or 12 plus 5, which gives us a positive 17. So simplifying the expression and identity, what was used to get to the next step. So we're going to come over here and we're going to look at our 5 times 2y minus 3. And we're going to start by distributing our 5 to the 2y. And then we're going to distribute our 5 to the negative 3 over here. And that's going to give us our 10y. And then our negative 15. And over here we have a negative 8. Now the 10y cannot be combined with anything, so that stays by itself. But if we look, the negative 15 and the negative 8 can combine together because they're both constants to give us negative 23. So that is the step that we did to combine the terms together. Our next one that we have is a little bit tiny bit longer. And we're going to take our negative 7 times x, and then we're going to take our negative 7 times negative 1. That's going to give us negative 7x plus 7. And then we're going to take 2x, 5 times 3. Actually, rather, we're going to do it on the next step of the problem. So we're going to take 5 times the 2x here. Doesn't really matter which one you draw it on, just for consistency's sake, we'll keep on going down. So I have my negative 7x, positive 7, and then this is going to become positive 10x, positive 15, and what I'm going to do, oh, that's not what I wanted to do. What I'm going to do is combine this 7x and this 10x to give me my 3x, because we're going to do 10 minus 7. Okay, so that was my 10 minus 7, gave me my 3x. And then my next step will be positive 7 and positive 15, which will give me an answer of positive 22. And that would be the next step in that process of solving and combining, which will give me my final answer of 3x plus 22. We have one more example right here. And as I was saying earlier, if there is no coefficient, like right there, we're going to imagine that there is a 1 in front of it. So negative 1 times y and negative 1 times 1. Negative 1 times y is going to give me negative y. Negative 1 and positive 1 gives me negative 1. And then over here, these are all going to stay the same as they were right here because we're not distributing anything, so we don't have to worry about those. What we do need to recognize is that negative y and positive 3y can combine, and same with negative 1 and negative 12, which is going to give us our negative 13, and 3y and negative y give us 2y in that equation. So those are our examples for that one. The application of these expressions would be like finding the perimeter of a square, finding the area of a rectangle. So if we were given that one of the sides was 12y plus 9, or even if they say x plus 9, like if it was a line drawn right here and we knew that this was y and this was 9, how could we solve for the area without knowing what that little variable right there is? But that's at a later date. We'll just go over what is actually written on here for now. So 2x, another way of writing this perimeter right here would be p equals 4 times 2x, because the perimeter of a square is 4 times the sides, right? So that's one way that we could write that. So 4 times 2x would give us 8x. So there's two different ways of writing those that equation right there, because the sum of all sides is the same as multiplying all the sides by 4, or multiplying one side by 4. And on this one down here, we have a side of 3, and since it's length times width, we would need to multiply the 3 times that 12y, and then we would also need to multiply the 3 times the 9, which would give us an area of 36y plus 27, and it would be yards squared on that particular equation if we were going to write the units. So this will be translating our equations into our algebraic expressions into phrases. So some of the things that we could say the sum of -3 and a number. So this is the word that we're looking at right here. Let's make that a little bit bigger so that way I can highlight correctly. So we're going to say the sum of -3 and a number, and some of the other things that we could put for the sum. We can put the total. We could put the addition or combination, and a couple other, but there's just a few examples of it for you. The next one that we have is going to be -5 decreased by a number. And so that decreased by a number could be -5 minus subtracted by there's a few other, but there's some examples for you. The next one we have is going to be 83 minus x, and the way we would write that, one of the ways we could write it is a number subtracted from 83. And just like up here, where it says subtracted by, subtracted from, decreased by, oh, let's go back to black so we're keeping it consistent. We could say decreased from. We could even just say from. So we could say a number from 83. This last one that we have down here is the quotient. Oh, I didn't mean to do that in pen. Let's try this again. The quotient of a number and 4. There's a couple examples of our phrases and algebraic expressions and how they would be related to each other. The next one we're going to translate the phrases into algebraic expressions again, using x as the number. And if you'll notice, comparing the last ones did not have coefficients. They simply had the variable and a constant. There was only one step that we needed to do for those equations. Now, if you notice, we have a constant and a coefficient, which means that we're going to need two vocabulary words to use to describe what is going on in the expression. So here we have product of and decreased by. Product of is going to mean this 5x right here. And then our decreased by means this -25 right here. So first we say the product of 5 and a number decreased by 25, subtracted by 25, minus 25. Any of those will be acceptable for the vocabulary terms. Next, if we look, one of the things that we need to know is what does 2 mean right here? When we're multiplying by 2, there's 2 different terms that we can use. We can either say twice, or we can also say double. Either one of those means multiplied by 2. And then the next thing we have is the sum of a number and 3, or we could say the total of a number and 3, or the addition of a number and 3. So there's a couple different options for the vocab that we can use in there. Here we have the quotient of 29 and twice a number. Again, this down here, because we're multiplying by 2x, or multiplying by 2 means that we could say twice or double. So if you look at that, that's how we can translate phrases and algebraic expressions back and forth with each other.